Okay, in this video we're going to look at functions. Before we define what a function is, we need to know what a relation is. So a relation is just a mathematical formula or graph or picture of something that relates two or more variables. Okay, for example, y equals x is a relation. So we'll take a look here. So mathematical graphical formula that relates two or more variables. That is a definition of a relation. So examples of a relation are y equals 3x plus 7. So that is a linear equation. It's a relationship between x and y. So how do we define y? Well, we define it in terms of x. Okay, so that is relationship. Another relation is the root of x equals 3y squared plus 1. So that's a relation. Okay, it's a mathematical formula. Here is another relation. So x squared plus y squared equals 25. This is the equation of a circle. And the circle has a radius of 5. So this is a mathematical relationship between x and y. You can choose a y value, solve for x. Choose an x value, solve for y. And they end up being points on a circle. Here's also a relation. So this is just a picture, a graph of a relation between x and y. Okay. And this could be a relationship between x and y. Depends on how you look at it. And same with this. So they could both be relationships between x and y if you think of them in some sort of context where the other variable is changing and not dependent on x. Okay, so here x has to be 7, but y could be anything. Okay, and here y can be negative 4 and x can be anything. Okay, so there's a relation. Now a function is a little bit different. It is a type of relation, but it's a special type of relation. It's a relation such that for every x value there is only one y. So for example, this works that way. If I choose x equal to 10, well, 3 times 10 is 30, plus 7 is 37. There's only one y value there. This is not a function, because if I chose x equal to 0, well then you end up just having y squared equals 25. And there are two y values that satisfy that, positive 5 and negative 5. So for one x value of 0, you get two y values. So there's more than one y value for that, so that's not a function. Okay, so here's a definition of a function. Okay, a function is a relation such that for each input, x, there is only one output. Okay, now for every output there could be more than one input, and we'll see examples of that in just a second. But here are some examples of functions. Okay, as we discussed before, linear, y equals 3x plus 7, that is a function. Because for every x value along here, you go up and hit that function, and you only have one y value. And this parabola, okay, that is another example of a function. Okay, so this is nicely done in vertex form, so you can graph it. Vertex is at 3, negative 4, so 3, negative 4. It opens up, okay? And so this, for every x value, there is only one y value. But for the y value of 0, there are two x values. So it's okay to have two x values for one y value, but there's only one output for every input. Okay? So you plug in x equal to 3, you get y equal to negative 4. You plug x equal to 2 in, you get y equal to negative 2. You plug x equal to 4 in, you get y equal to negative 2. So when I plug in 4, I only get one output. When I plug in 2, I only get one output. They happen to be the same output. That's okay. Right, a couple more examples. here is a cubic function. Okay, so y equals x cubed. Well, how do we get this? Well, if you just look at the positive side for a moment, when you take numbers and cube them, they get bigger. 0 cubed is 0. 1 cubed is 1. And then so on. 2 cubed is 8. And so on. It gets bigger, bigger. Kind of like a parabola, like when you square numbers, only this goes up faster. Now, in a parabola, when you square negative numbers, they become positive, so it goes up like this. But when you cube negative numbers, you're multiplying a number by itself 3 times. You cube negative numbers, you get negatives. So it opens down like this. And that is a cubic function. That is a function, because for every x value, there's only one y. And a quick test for this graphically is if a vertical line never cuts the graph more than once, then you have a function. But if at one place it cuts it more than once, you have a relation, but not a function. Okay? And then there's this one, the root of x. Well, because you can only take the root of positive numbers, and the square root of a number is positive, this is what you get. Okay, the top half of a sideways parabola. So the square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Okay? Square root of 16, 4. So it comes down slower. Now, you could have the cube root of x, and that looks like this. Okay, so kind of like square root of x, when it looks like that on that side, but you can't square root negative numbers, but you can cube root negative numbers. Okay, so if you think about it, it's possible because you can cube negative numbers and you get negatives, but when you square negative numbers, you get positives. Okay, so this is a cube root graph. 1 over x, well, you can't divide by 0, so x can't be 0. So when you're looking at this, what this graph might look like, you're doing 1 divided by numbers that are bigger than 0, so let's look at positives. 1 divided by a really small positive number, like 0.0001, is really big. 1 divided by a really large positive number, so 1 over a million, is really small. So we get this for the graph of 1 over x when x is positive. When x is 1, 1 over 1 is 1. So 1 over small numbers, big. 1 over big numbers, small. And then 1 over negative numbers, well, it's the same idea, but it's over here. And as you can see, 1 over x squared looks very similar, but when you square negative numbers, they become positive. So this part here that was down on 1 over x flips up. Okay? So this would be the graph of 1 over x to any odd degree, like 1 over x cubed, 1 over x to the 5th, 1 over x to the 7th, because the negatives stay down here. It'd just be sharper. And this is what this graph would look like if the exponent was even, like 1 over x to the 4th, 1 over x to the 6th, and so on. It would be both pieces are up. Now you cannot divide by 0, so it doesn't exist at x equal to 0. And because it never touches the horizontal, the x-axis on each one of these, y will never equal 0 either. And we call these two axes asymptotes. Okay, so asymptote is spelled like that. Okay, so the curve never touches it, but it comes close to it, and it's an asymptote. Okay. And then the last one we're going to look at here is the absolute value graph. So absolute value, these bars beside the x, means make everything positive. So if x was 1, it just stays as 1. But if x is negative 1, the absolute value of negative 1 is positive 1. So when x is negative 1,000, it's positive 1,000. When x is 1,000, it stays 1,000. So what happens for graphing absolute value of x is it's like graphing y equals x when x is positive, which is just this diagonal. But when x is negative, if it was y equals x, this would just come down here, like this. But because we take everything negative and make it positive, it flips up here and we end up with this v. Okay? So a couple more examples of this absolute value graph is maybe this one here. Okay? Absolute value of x squared. Well, the absolute value has no effect because x squared is already always positive. So if you square a number, it's positive. Take the absolute value, doesn't change it. So there's the absolute value of x squared graph. Okay? If I wanted to look at this one, absolute value of x squared minus 4, well, you take the graph of x squared minus 4 and draw it. It's x squared shifted down 4. Okay? So what we do here for that one, okay, is I'm just going to draw it in dotted lines, or dotted curve. So it would look something like this. And that would be at -4. But because you're taking everything that's negative and making it positive, this part gets flipped up. All the parts that are between here and here get flipped up. And the graph looks like this. Okay? And that's x squared minus 4, so that factors to x minus 2, x plus 2, and the x-intercepts are -2 and +2. And that would then be at +4. So the dark graph here is the graph of that. Okay, so looks like that red graph there. And another one, another example of this would be, or a couple of examples are right here. Okay, so absolute value of x minus 2 means take the absolute value of x graph, which is the v, and subtract 2 from each y value so it gets shifted down. Because the -2 is outside of the absolute value, it's okay. This one here, x minus 2, well, you think of the graph of y equals x minus 2, it's this, it goes through -2 on the x-axis. Okay, but because the absolute values are on the outside of the whole thing, you take this and you flip it up because it has to become positive. And this is the graph of that. And so those are examples of some functions. What do some non-functions look like? Well, so some non-examples here. Well, here is one. So x squared, or x equals y squared. That's just a sideways parabola. If you had to solve for y in this to see what it looks like, well, y would equal plus or minus the square root of x. Okay? Because when you've got x equals y squared, when you got to get rid of the y squared, you got a square root. But positive and negative values work for this, so that is the function of x equals y squared. It's not a function though. I said function, it's not a function, because for this x value here, there's 2 y values. Okay? So because there's 2 y values for one or more x values, it is not a function. Okay? So that is what that one looks like. Another one that is not a function is the circle. Okay? So we talked about this already. So x squared plus y squared equals 25, which is r squared. If you had to define this for y, well, you do 25, bring the x squared to the other side. So that's what we get here. Okay? It's the same thing as that. And then when you want to solve for y, well, you go plus or minus square root of that. Okay? So that is the plus is the top half of the circle, and the minus is the bottom half of the circle. And it's not a function because for this x value here, there are 2 y's. Okay? So it does not pass the vertical line test.